What is container? So a container is a software that contains an application code and all its dependencies. So what are the dependency an application have for running itself? So those all contains by the container. Now let's understand container with the help of this diagram. In this diagram you will see there are three containers. One container we are using for Java based application, another container we are using for .NET based application, and the third container we are using here for .NET Core application. And all these containers running on the top of host operating system kernel. So the container is not having its own kernel, it uses the host operating system kernel. So we will see in the container one, we are running a Java based application. So for running the Java based application, we need Tomcat as a web server, we need a operating system as well. So as operating system we are using Debian. Similar way to run the SQL server on the Ubuntu machine, we need Ubuntu, we need .NET. So this is the way how the SQL server is running on the top of Ubuntu. In the third container, we are running the ASP.NET Core application. So for running the ASP.NET Core application, we need a base operating system. So we are using here Ubuntu as a base operating system, .NET Core as a runtime, and then ASP.NET Core application. So we will see in all these three containers. For running an application, everything is the part of the container. So container is a complete package which is containing the base operating system, which is containing the runtime, which is containing the runtime environment variable, and which is containing the complete application code. So the containers enables an application to run quickly in an isolated environment. So these containers are isolated from each other. Container also provide a smooth migration from one computing environment to another. So let's say your application you are running as a container on the machine 1 and the same application you want to run on machine 2. So on machine 2 it can be migrated easily. So in machine 2 also don't need to do any environment specific setting for running that application, because all the environment specific setting for that application already packaged with that container. So container is a complete package containing everything to run an application. And containers share the same operating system kernel. So wherever container you have installed, let's say you have installed the Docker on the Windows machine. So whatever the Windows machine kernel, we have the same kernel used by the container. So it's not having the separate kernel as we have in the virtual machine. So in virtual machine we are having everything separated, but the container is using the host machine kernel, the host machine things. And the container works with all the major Linux and Windows server. So whatever the Linux and the Windows server are available in the market, so container can work over there. So you can host your Docker application, like Docker based container application on Windows machine and even on the Linux machine also. So this is all about the container you should know. Container platforms. So let's see what are the various container platforms are available. So one of them you can use here. Here in this list, I'm sharing the most popular container platforms the people are using across the world. Actually, containers came from the Linux platform. So let's understand the various containers platform. So the first one is here the Linux containers. So Linux containers are based upon the LXC. LXC is an operating system label virtualization method for running the multiple isolated Linux system. The second one is here Docker. Initially, when the Docker was introduced, Docker also used the Linux container based environment, but now they started to use the Docker Swarm. So Docker Swarm is an open source container orchestration platform which enables to run the multiple containers. The third one is a Kubernetes. So Kubernetes is an open source container orchestration platform from the Google for managing the thousands of containers. So if you are willing to manage, if you're willing to automate the thousands of containers, so Kubernetes is the best choice. So there people didn't prefer the Docker because Docker is fine for the medium scale containers management. If there are thousands of containers together you need to run, so there the Kubernetes will help you. The fourth one is here the Red Hat OpenShift. So Red Hat OpenShift is an open source container application platform based upon the Kubernetes container orchestration. So Red Hat OpenShift is also based upon the Kubernetes. Even Kubernetes you can also use with Docker also. So in place of the Docker Swarm you can use Kubernetes also. The next one is the DCOS. So DCOS is an open source distributed operating system based upon the Apache Mesos distributed system kernel for managing the containers. Why containers? So now the question is here, why to use containers? Being a developer, being an administrator. So now let's understand why to use containers. Being a developer. So for developers, the containers help us to quickly create ready to run packaged application at low cost deployment. So when you're going to deploy your application, so the cost of deployment would be less. Let's say you are building a microservices based application. There you have created multiple microservices. So obviously now you need to host it on the multiple virtual machine. So instead of paying for multiple VMs, you can deploy those microservices as a container in the isolated environment. So obviously you are saving the cost of deployment here. The next point is here the automate the testing, integration and packaging. So the benefit is here when you are building your application, so that time we need to set up so many environment specific setting. We need to set up the testing environment and all the things. So with the help of containers also you can automate the testing and everything what are the application needed to run itself can be the part of the container itself. It reduce or you can say it eliminate the platform compatibility issues. So this is actually the main benefit of using the container. So when you are creating the container package, so whatever your application needed, whether it's a OS label, whether it's a environment specific level, everything is the part of the container. But in case of virtual machine based deployment, you need to do the configuration again and again. So in container based deployment, the platform specific compatibility issues are nothing, or you can say these are zero. Container also support the microservices development. So if you are following the microservices based architecture, so their container will help you a lot because the microservices deployment can be done easily with the help of containers. So these are the few points I shared with you from the perspective of developers why you should learn containers. Now let's understand from the perspective of administrator why the administrator should care about the containers. For administrator, the containers improve the speed and the frequency of release and the reliability of deployments. So benefit of using the containers is you can improve the speed of deployment because they are not having the platform specific issues usually we have with the virtual machine. So that's why containers are also useful for the administrative purpose. And the containers make the app lifecycle efficient, consistent and repeatable configuration where you need to configure once and run many times. So this is the most important benefit. Usually in case of migrating the application from machine 1 to machine 2, there are so many compatibility issues we face. But after using the containers, you don't need to worry about such things because container having everything. They contains everything in itself. So this is making the app lifecycle efficient and consistent because now you have to configure the things once and repeat it multiple times. It eliminates the environment level inconsistency between the production, testing and the development environment. So these are the main issues the administrator face while deploying the things. So now you don't need to worry about such things. So these are the reason why the people started to use containers. So containers are making our life easy as it was difficult, or you can say it was not so easy when we used only virtual machine based deployment. Virtual machine versus containers. So containers may sound like the VMs, but both are different things. So in this slide, we will understand how the virtual machine are different from containers. Now let's have a look at the virtual machine. So let's say you are having a host operating system. It can be your laptop, it can be a host in your on-prem, it can be the host in the cloud also. So host having its own operating system. So this host can have the multiple virtual machine with the help of hypervisor. So hypervisor is a software tool which enables to create the multiple virtual machine. So you can see there are 3 virtual machine here and each virtual machine having its own operating system, having its own application. So these 3 virtual machine are running in the isolated environment and each machine having its own operating system and the host operating system also having its own operating system. So this is the way how the VMs has been created and how the things are managed here. Now let's have a look at the container also. If you will see in the container, what are the host you are having? Let's say the host can be your laptop, the host can be your server in your on-prem, the host can be your in the cloud. So host having its own operating system and in that host you have to install the Docker. So Docker having the Docker engine. So it's not having the separate operating system as the VM having. So Docker engine is here responsible for running all the containers. So here also in the picture there are three containers based application like application 1, application 2 and application 3. So here Docker engine is helping us to run all these three containers in the isolated environment. So here we don't have an extra layer of operating system as we have in the virtual machine level. So when you will start the containers based application, it will start faster as compared to start up a virtual machine. Now let's understand the difference between virtual machine and containers in details. So here I'm just sharing few points how the virtual machine are different from the containers. So virtual machine is a hardware level virtualization, but container is a operating system level virtualization. So in the VM, what we do, we divide the compute resources of the host machine, but in containers there is nothing like that. Virtual machines are fully isolated, but containers are not fully isolated. There is always a process level isolation. So what are the containers you are having? They runs just like the process. The VM also having the isolated operating system. The containers are not having the isolated operating system. They are the isolated process. They are having the isolated file systems. So whatever the files are used by the containers, they are isolated from others containers files. The virtual machine having its own kernel, but containers use the host machine kernel. Virtual machine slower in startup. So when you will start a virtual machine, so all the things would be loaded. Obviously it takes time, but when you're starting a process, so process will start faster because our machine is already running. You need to just start the process. So that's why containers are faster in startup. In virtual machine, there are many startup process. So basically it's a complete operating system booting is happening when you are starting the virtual machine. But in containers, there is a single startup process. So that's why it is faster. Virtual machine is also having the upfront resource allocation. So when we create a VM, we already decide the RAM, we already decide the operating system, we already decide the physical hard disk also. So everything is already decided. So there is a upfront resource allocation whenever you are creating a virtual machine. But in case of container, there is no need to define the upfront resource allocation for running a container based application. Containers and VMs together. So containers can be used with virtual machine as well. It doesn't mean containers you cannot use with the virtual machine. So let's have a look how we can use the containers along with the virtual machine. So this is the diagram here. So if you will see in the diagram, there is a physical server, and this physical server having the three different virtual machine. So using the hypervisor, we created these three VM, and each VM having its own operating system. And what we did here, at the two VMs level, let's say VM1 and the VM2, we install the Docker. And the Docker having its own container based application, it's application 4, application 5, and the second VM also having its own application, application 6. And the third VM is not having any Docker. It's not having the containers. So this is the way the containers can be used along with the virtual machine. So let's say if you're creating a VM in the cloud, so that the cloud level VM, you can install the Docker and you can create the containers over there for running your application. It doesn't mean you cannot use other containers along with the virtual machine. It can be used. So this is the way how the containers and the virtual machine can be used together for building and deploying your application.